Hi dear all, welcome you all to the brilliant group of institution. Here we are going to discuss the most important questions from the chapter coordination compounds. Let's start with question number 1. There is a compound dear all, considering H2O as a weak ligand, the compound is given MnH2O6, right? MnH2O6 time the entire charge is 2 plus, all right, will be how many unpaired electrons are there? So simple question dear all. The manganese is the central metal atom given its atomic number is mentioned dear all 25. So what is the configuration dear all? Argon, argon atomic number 18, next 2 electron goes to 4s and remaining 5 electron goes to 3d. So the orbital configuration or the electronic configuration of manganese is what? Argon 4s2 3d5. all right, in this question this is the ground state. Now in this question you can, on the complex you can able to see what is the charge of manganese, right? H2 is a neutral ligand, so 2 plus is the entire charge of manganese because MnX aqua charge is 0, entire charge is plus 2. So what is the charge of manganese dear all? Mn plus 2 or 2 plus. That means 2 electron you can leave from 4s. What is remaining? 3d5. They already said H2O you can consider as a weak ligand. Weak ligand, the electrons will not undergo pairing. So dear all, d5 means how the 5 electrons are situated in the d orbital as single occupation, right? So total there are 5 unpaired electrons. So what is our answer? Option 3. Hope you clear. Next question dear all, question number 2. Which of the following coordination compound would exhibit optical isomerism? Very careful dear all. In order to show optical isomerism, a simple trick let us discuss. In order to show optical isomerism, the complex should contain at least 2 or 3 identical bidentate ligand. For example, En twice. Ethane 1,2-diamine is a which one? Bidentate ligand, right? So En twice or En thrice should be there, and OX twice, oxalate twice or oxalate thrice. So what is the first condition in order to show optical isomerism? The compound should contain 2 or 3 identical bidentate ligand. That's not enough. What is the second condition? Second condition is their mirror image should be non-superimposable. When you take the mirror images, that should be non-superimposable. If these two conditions are satisfying, we can able to say the compound can exhibit optical isomerism. Dear all, question number 1 or option number 1, tris-ethylene diamine. What is tris-ethylene diamine? En thrice. Okay, and cobalt is the metal, and they're all bromine is there. En is a neutral ligand. In order to make overall charge 3, there should be Br3. This condition is satisfying or not? Yes dear all, En thrice is there. Yes, it's possible. It's having only pentaamine and nitro. All are monodentate ligand. It cannot show. Diamine dichlorido. It cannot show because only monodentate ligand. And trans dicyano bis ethylene. They're all trans. If cis and trans is given, trans isomers mostly when you take the mirror images, they are superimposable. Cis is the only one mostly optically active. Okay, so here we have an answer. Which one? Option A, because it contains En thrice, and when you take the mirror image of that also non-superimposable. Let's go to question number 3. Which of the following is considered to be an anti-cancer species? An anti-cancer drug is there. What it is called? Cis-platin, right? Cis-platin. It's used for a anti-cancer. It's used as an anti-cancer drug. Cis-platin is what? PTNH3 twice, Cl twice, and it should be a cis form. Cis-platin. The first complex is in the trans form. It is not the compound. That is not the compound. For it is cis isomer, right? Cis, the same side. So what is anti-cancer drug dear all? Cis-platin, PT, NH3 twice, Cl twice, and they should be arranged in a cis manner. Question number 4. Which one of the following pair represent stereoisomerism? There are two types of isomerism, structural and stereo. In structural isomerism, we studied ionization isomerism, linkage isomerism, hydration isomerism, and coordination isomerism. Which all are stereoisomers? Which all are dear all? Geometrical and optical isomerism. So option 3 is the correct answer, right? Option 3, optical and geometrical are the stereoisomerism. Question number 5. The diamagnetic species is. Among this complex, which is diamagnetic, dear all, just aware about the complexes, dear all. The central atom here, nickel, cobalt and cobalt, right? Please analyze about the ligand. You know, cyanide is a strong ligand, chlorine is a weak ligand, and chlorine here is a weak ligand, fluorine, you know, halogens are weak ligand. There are question which is diamagnetic. What is the condition to be diamagnetic? The all electrons should be paired. All electrons should be paired. In which system the electrons are paired here all? Option 1. Because in option 1, cyanide is the ligand present. You know, cyanide is a strong ligand. It make pairing of electron and there is no unpaired electron. It will be diamagnetic in nature. Clear all? Question number 6. The correct order for the wavelength of the absorption in the visible region. There are many complexes are given here. All the cases, central metal atom is nickel, ligands only the difference. NO2 which one? Nitrito, N is there, amine is there, aqua is there. Dear all, there is a relation with the energy. You know, crystal field is splitting energy as per spectrochemical series. You know which is the strongest ligand and which one having highest energy to make more splitting, right? Dear all, among amine, aqua and nitrito, which is the strongest ligand, dear all, NO2 is the strongest ligand, then amine is the strongest ligand, and weak ligand is which one? H2O. This is the order of the energy, crystal field splitting energy. But question they are asking with the wavelength, dear all, you know, energy is inversely proportional to lambda, because energy is equal to what? Hc by lambda, where energy and lambda is inversely proportional. So dear all, the question, what is the correct order of wavelength? So higher the energy, which having least wavelength. So NO2 having least wavelength. So this is the energy order. So what is the wavelength order, dear all? We can able to say NO2, then amine, then which one? Aqua. This is the correct order of their wavelength. Where you can able to see this option, that is in option A, no doubt. Clear all of you? Next question number 7. Which of the following compound shows optical isomerism? In part 1, I already told you what is the condition in order to show optical isomerism. The compound should contain 2 or 3 identical bidentate ligand, where you can able to see this is monodentate ligand, monodentate ligand, monodentate ligand. Option 3, that is the only one contain 3 oxalate, so it can show optical isomerism. And what is the one more condition? Their mirror image should be non-superimposable. Yes, of course you can able to see that its mirror images are not superimposable. Question number 8. The ligand in anti-cancer drug cisplatin. You know, dear all, cisplatin which contain PT, NH3 twice, Cl twice. So they're asking you what are the ligands present in this complex, dear all, which all amine and chlorine. These are the ligands. That's option A is the correct answer. Next question number 9. The coordination number and oxidation state of this complex, dear all, K3 and CrC2O4 thrice. Yes, this is the compound, dear all, given. They're asking you what is the coordination number. What is the coordination number? What do you mean by coordination number? It is the number of what is the number of sigma bond created by the ligand with the metal. Cr is the metal, and you know C2O4 is what? Oxalate. You know, oxalate is a bidentate ligand. So one oxalate can give you 2 sigma bond. So total there are 3 oxalate. So total how many sigma bond? 1, 2, 3, 4, 5, 6. So coordination number is what, dear all? 6. What about second question? What is the oxidation state? There are 3 potassium, you know, 1 potassium charge +1, so 3 potassium +3, chromium X, and oxalate is -2, 3 oxalate mean -6, overall it's neutral, so X equal to what? +3. So coordination number 6 and oxidation state 3. The answer is what? Third one. Last question, question number 10. The octahedral complex will not show geometrical isomerism is, dear all, in octahedral complex. Octahedral complexes, when you consider octahedral complexes, only 2 species shows the isomerism. One is the type MA2B4 or MAA4B2. This will show cis-trans isomerism, that is our geometrical isomerism. Another type is which one? MA3B3. It shows which one? FAC and MER, facial and meridian isomerism. And other systems, they cannot show any other isomerism. So in octahedral complexes, which will not show geometrical isomerism, which one? A possible, they're all B, MA5B, such kind of set cannot make any kind of which one? Isomerism. 2 is the correct answer.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.